For most assignments I actually give p-values and means. Your research report assignment might require you to generate these yourself, do your own analyses. But I'm starting at this point because the basic statistics you need to understand is that when a p-value is less than 0.05, the result is usually considered statistically significant. And when the p-value is bigger than 0.05, then the result is not statistically significant. You need to understand a little bit more than that. If you've done introductory stats, you're good to go. But for example, here you can see the difference between, there is a difference between A and B. You know, B is bigger, the number's bigger, whatever the dependent measure is, but that's not statistically significant. So you don't get to talk about a difference. There is no difference. Your sentence talking about that difference, that comparison, should begin, no difference was found between, and then state the conditions in a meaningful way that I'm going to explain in a moment. No difference was found between. There was no significant difference between. There was no difference. Say it. Say that language. Don't say something like, the difference was small but not significant. Don't say that. It's not a small difference. It's an absence of a difference. Okay, and this is fundamental statistical understanding. Yes, I know you can see that 18 is bigger than 17, but this number here, this p-value, is saying that no difference was obtained. And that's the language you need to use. So none of this business like, oh, it was nearly significant or close to significant. It was slightly larger. Slightly larger doesn't mean anything, okay? Stick to no difference, no significant difference, or a difference was found, and save that for when it's statistically significant. So this is usually what you've got to work with, but there's got to be more. And what you need to add to this is your understanding of what's actually occurring in terms of the direction of the effect. I mean, the direction, yeah, you can just look at the means to see the direction, but the meaning of the dependent variable, well, that's not here anywhere. The meaning of the conditions, you've got to integrate all this information. So I'm just going to create a research context. It will differ for the research report you're doing, but this is the kind of thing you need to jot down. So the dependent variable is a score on a questionnaire scale where higher means more anxiety. That's absolutely necessary. Condition 1 is the high load condition. Condition 2 is the low load condition. Good. The test of the difference between condition 1 and condition 2 is 0.032. Looks statistically significant. Good. And those are the two means. So you think, hang on, what's this adding, that very last dot point? It's the direction of the difference. Okay, now you don't need to state the means in these sentences, but you need to look at the means and know that, well, it was higher for condition 1. Can you see how we're going to put this together? 53 compared to 40, higher means more anxiety. Condition 1 is more anxiety. High load is more anxiety. Just put them all together, and it's statistically different. Statistically significantly different. See, so you need all this information. You can't start putting it together without all that information. So let's start. The difference between condition 1 and condition 2 was significant. It's not a terrible start, 0.032, but I've got that woman scowling at you because, what direction was the effect? What does that mean? What? Well, yeah, it's not enough. So, okay, let's add a bit more information. The direction of the effect, participants in condition 1 had significantly higher scores than participants in condition 2. We're getting there. That's the direction of the effect. But yeah, she's still scowling at us. Participants in condition 1 were significantly more anxious. We've got the meaning of the dependent variable. That's excellent. They're more anxious than participants in condition 2. There's really only one more step. We haven't told the reader what the conditions mean. Participants in the high load condition were significantly more anxious than participants in the low load condition. Okay, P equals 0.032. There are no means in that sentence. You don't need to worry about means, at least in the assignments I set. But you can see it's got all the information and it's time to celebrate. Now, that essential information needs to go into every sentence. I strongly, strongly suggest you do one sentence per p-value. None of this, trying to be fancy, all p's greater. No, don't do that, okay? Or, respectively and stacking up 2 or 3. Don't do that. One sentence per p-value, okay? Keep it neat, make that sentence, have all the information. Use words like bigger, smaller, greater, weaker. to describe the direction of the effects. You know the direction by looking at the means. Describe the conditions or label them meaningfully and make sure they connect to your hypotheses. Don't do that thing I mentioned earlier where you're describing something differently each time it comes up and ruining any thread. Make sure you're describing it in much the same way as you did in your hypotheses so that the reading, oh yeah, okay, so that was a hypothesis. Put them in the same order as the hypotheses, make it even easier to read. Make those connections strong. Cite the p-value, include the meaning of the dependent variable. At all times ask, am I actually making the results easy to understand? Or am I asking the reader to do more work? Think back to that very first sentence. The difference between condition 1 and condition 2 was significant. Oh, and I've had people in remark meetings saying, well, you can work that out. You've just got to go back to the method section and then you've got to go back to the, what? No, that's not how you communicate in science writing. Yes, you can work it out like some kind of puzzle. Do you think you're going to get a high mark if you give the reader, the marker, a puzzle to solve? No. So make the results easy to understand. A lot of result sections are short, but you can see a lot of work goes into each sentence. This is an entire result section, one sentence per p-value. If you've got more p-values to report, you're going to need something a bit longer, but that's almost that is an entire result section without a graph. And as I've said a few times, I don't require means. Ask your tutor if they require means for that particular assignment. To repeat this, ensure the language you use to describe the effects matches the introduction, particularly the hypotheses. Do them in the same order. Take care with AI. You'll be surprised how good AI seems to be with this. You can literally just take a screenshot of some of these results information sheets, chuck it into AI. It'll create sentences and then you can clean it up. But you've got to be very, very careful. And you do need to clean up. You do need to look carefully at the output and, oh my God, I've got a bit of work to do here. AI will want to give you the means again, even if you don't need to, so get rid of them. AI will, if you don't tell it the analysis, it will start making stuff up. ANOVA, post hoc, get rid of it. That's fabrication, that's hallucination. AI will also want to interpret the results. And when you're writing a research report, you don't do any interpretation in the results section. You literally just say, this is what was found and whether or not it was significant, okay? It's going to want to interpret. Just tell it not to do that or get rid of it in the output. And also, big grain of salt on anything with AI. You just got to check to see whether it's completely and utterly wrong, because I've seen this many times in reports I've marked. It's completely wrong. And no one's actually bothered to actually check and realize that it's describing things completely incorrectly. And, you know, matching up the language is something that AI won't be able to do unless you include that in the prompt. So yes, that's the first dot point and the last dot point on this slide. You're going to have to put some work into doing that. So I don't know, with all that fixing and poking around, AI might not actually save you much time. But it's one of the few sections where I would say, look, you might as well have a go and see what it does. It might help you. You're just going to have to take a careful look at it. Graphs and tables, Academic Writer has exemplars. Academic Writer is where I got the exemplars I'm about to show you. The golden rule for writing research reports is a graph or a table for the same data, never both. If you can't decide between them, just ask yourself, what's better? What's going to communicate these results better? It's almost always a graph, I've got to say, almost always. I often just tell tutors, just tell them to draw a graph because we're sick of questions, graph or table. Think it through. A graph shows you your results visually, instantly. Yeah, almost always go with a graph, but it might depend on the nature of the data. A table might be better for some kinds of more complex data. And here's how you do a graph. I pulled this from Academic Writer just recently, and it hasn't actually changed in 4 years, so it's unlikely to change no matter how old this module gets. But what I'm looking at here is there's a figure label, figure 1. It goes above the graph. The bars are separate. The bars are coloured and striped, and I've had tutors say, oh, you can't use colours. Well, no, this is from Academic Writer itself, so they're wrong about that. The axes are labelled. Okay, mean number of gestures, gender. You've got to click the plus sign on Microsoft Excel to add the axis label element. Okay, if your graph isn't giving you axis labels, click the plus, add the element, label the axes. There can be a note at the bottom of a graph, but it's not the caption. The caption's actually here. So if you want to describe what's in the graph, put it in the caption at the top, and the note is entirely optional. In terms of, you might think, oh, that's easy, I'll just chuck my data in and go for it. You have to think through your data though. If I was doing lots of statistical comparisons within women and within men, I think this kind of graph would go well. If, on the other hand, every single comparison of note and every single hypothesis I was testing was men compared to women, so large gestures, I'd want those two green bars right next to each other. Do you see I'd do the graph in a completely different way? The graph needs to match the statistical comparisons. It needs to make sense because it's going to be right next to the statistical comparisons and it's going to help the reader understand the results. So yeah, if you're comparing women and men on each of these measures, put those bars together in lots and lots of pairs. This kind of presentation here suggests that it's the differences between large and small that are significant. And your comparisons are going to be large versus small, and then maybe an overall. Women had bigger hand gestures than men, presumably is the finding. Okay, so can you see how that makes a difference? These are discrete variables. Why would you do a line graph if you have a continuous variable like year or reaction time's usually a dependent measure, but something that's continuous, because you're only really doing a line graph when something between the little dots can be interpolated, can be meaningful. And there's nothing, I suppose, between large and small could mean something. What's halfway between one hand and two hands? It's not meaningful. So bar graph, very suitable for that kind of data. For years where you're looking at trends, maybe your stats are trend analysis. Yeah, nice line graph, makes sense. Same rules apply, figure label at the top, caption at the top, note is optional, axes labeled. And the other thing, might come up on a later slide, oh, here's another table. But just the other thing, when you've got these tables and figures there, you need to refer to them in the text. So you'll see that from the exemplar I put up right a few minutes ago. See figure for these comparisons. That's all you need. See figure 1, see figure 2. It connects the text to your table or figure. Okay. About tables in APA format, if you must do a table, then there's a strict rule here that I'll state for you. No vertical lines. It's just an APA rule. I don't know, someone in APA headquarters doesn't like vertical lines. It's been around for decades, but there you go. Okay, don't use vertical lines. That's why it's all looking very, very horizontal. I've kind of mentioned this already. The best graph depends on what was actually tested. It does depend on your hypotheses and on your comparisons. So don't perfectly format an APA graph or get AI to do it and think, oh, well, it's got to get full marks. It's perfect. Depends on how you explain things. Depends on how you presented your results in terms of what's actually perfect. But that's all the information you need to actually finish your results section. So I recommend you finish it the moment you have your results and you've got all that information. Graph, 1 sentence per p-value, 1 sentence referring to the figure, or blend that into one of the other sentences. You're done. That's all it is.